So today I'm actually presenting a work that's already published in Journal of Economic History, but to fulfill the faculty's award conditions, so we have to present it here again. Okay, so it's a joint work with Ajahn Jessica Banyongrat. I think she's here with us today as well, and it's a paper on canals and orchards. So basically, we are assessing the impact of transport network access on agricultural productivity. And we are taking you back in time a bit to the time of King Chulalongkorn in 19th century Bangkok. Okay, next please. Okay. So thank you. So let me motivate you a little bit why we come up with this paper. So basically, we ask an old question in development economics and trade economics that what is the impact of transport infrastructure access on economic development? Okay, so there are plenty of research that try to use historical data following Vogel's work back in 1964. So he's a Nobel Prize winner. So basically, there are words, for example, in India or United States that show that there are aggregate spillover effects of transport network development on agents' locality, like market integration or even agricultural productivity. But most of the research actually look at the aggregate level, meaning that at the agent's locality, saying that if there are rail lines passing through this district, what is the effect on this district's productivity? Okay, so because of data limitation, there's little discussion about to what extent that those aggregate effects are actually driven by agents that located directly on the transport infrastructure, i.e. on the lines, instead of like you have the spillover effect that you have lines passing through your districts or sub-districts, for example. Okay, thanks. So this paper actually takes the research question into a more micro level, using a very unique data set from Bangkok 19th century. I'm going to talk about the data set later. Okay, so basically, we are asking more specifically how whether the agents on the lines of transport actually benefit more than those within the same locality. Okay, so here, more specifically, we are looking at canals as a transport network and effect on orchard productivity. So let's have a look at the historical background a bit. So some of you might have heard that Bangkok was actually called Venice of the East. So basically, there were loads of canals in Bangkok and Thonburi side. And canals are one of the oldest forms of transport routes. And back in 19th century Bangkok, this is also reflected in Sir John Baring, a diplomat whose name given to the treaty, Baring Treaty, that generated kind of more integration of Siam into international trade. But that's different things. So basically, he said that the highways of Bangkok were not roads or rail lines, but actually canals and rivers. But canals at times were built for purposes that are actually exogenous to orchard production. So they were built for modes, regional transport, shipping routes for rice or sugar, or enlarging arable frontier for land for rice farming. So this is actually good for our identification strategy that they were built for the purposes exogenous to our orchard production. So we can argue that it's not that because in this area there's high productivity or households with high productivity, so then their demand for canals to be built on. But canals were built on the purposes that exogenous to orchard production. Okay, yeah. Next, please. Thanks. So this, if you can see, hopefully is big enough, not in my mobile screen, but hopefully on your computer. So you can see a network of canals in Bangkok. So the dark line is the Chao Phraya River. And then you can see that the lighter lines, some of them were actually straight lines, showing that most of them were man-made. Okay, man-made canals during that time. So this is just to see how the networks were connected. Okay, next. Okay. Although we claimed that canals were built for the purposes exogenous to orchard production, but from the historical account, most orchard cultivators actually marketed their production by using boats and canals and transported their products to, say, a floating market or the neighborhood. Okay, so here from the historical account, it's possible that canals afforded orchard households greater access to transport and transport cost savings. And then we made a claim that possibly that because of this, they have more incentive to be more productive if they are on the canals. Okay, next, please. And this is just to give you an atmosphere of that time of the floating market. Okay, yeah. Okay, next. So here before going to the empirical section, okay, so I'll try to say, okay, so here we actually estimate transport cost saving from having canals just to illustrate the situation for you. So basically we claim that for one person, on average, could be he or she could be 62 kilograms, and one rowing boat that you saw in the earlier pictures could carry about 6 persons. So it's equivalent to 300 something kilograms. So from the member of Toby Julasap, okay, he grew up in a durian orchard in Thonburi side. He would go with his mom to the market every weekend. So if say that 2 persons were already in the boat, that would be the space left for about 83 durians. Okay, and his house was 500 meters from the natural canal, Klong Bangkok Noi, but theirs was actually on Bang Khun Non Canal, which was a man-made canal. So, which is 500 meters from the natural canal. So we made an assumption that if without this man-made 500-meter canals, okay, he and his mom had to carry the durians to the natural canal to go and then boarded the boat and then row to the floating market. Okay, so we are calculating how much time that can be saved by that man-made canal. Okay, so if they were to walk 500 meters, taking about 5 minutes and carrying 83 durians, so they would take about 85 to 135 minutes, and that would make him instead of getting up at 5 a.m., he and his mom had to get up at 2 something or 3 a.m. in the morning. So you can see the difference. Only 500 meters made this much difference of time. And if we calculate it in terms of labor cost, okay, from the wage estimated at that time, if they hired labor to carry the durians instead of putting it on the boat and on this canal, okay, they had to pay about 10 to 16, 17 days of adult nutrition from rice. So that's that's quite a lot of cost, okay, that can be saved by having just 500-meter canal docking in front of the house. Okay, so now you get some feeling. Now we are going to do actual empirical work. So we obtained the data. We construct a household data set from a very unique all-sheet land list or tax records back in the time of King Rama V. And then Jessica bumped into this record at the Department of Lands Museum, okay, almost 10 years ago. Okay, and we used about 8,000 all-sheet deeds covering 19 districts, or equivalent to 42 modern sub-districts in Bangkok. In the next slide, we show how the actual deed that kept by the museum looked like. So you can see that we know the location, sub-district, province, and plot. In parentheses, Kanat is the unit instead of square meter. So we use kind of kanat to measure swan. Our shit back in time in Thailand. And then below, you can see that it showed that on each side of the plot, okay, is adjacent to what. So here in the second line, it says sort clong, meaning that it's next to a canal. Okay, so it means that we can identify which property was actually adjacent to canal and what kind of canal as well. I'm going to talk about it later. And next is the tax. Okay, could you go back a bit to the previous slide? Sorry, is the tax assessment. So this is how much the tax would be paid by the estimation at the beginning of each reign. That would be officers going to the gardens and then count the trees and what kind of trees, and then they jot down. Okay, once a reign. Okay, next please. Okay, for the sake of time. So here on the right hand side of the slide, you can see the tax schedule that it was used at times. So the tax varied according to the types of trees that you grow. For example, durian was most valuable one. Okay, then you paid more tax, and the more the trees you grow, then you pay more tax as well. So tax assessment, although in the previous tax deed, we don't actually see what they actually grow, but the tax rate that they pay should approximately tell us something about how productive they are, how many trees they grow, and how valuable those trees were. Okay, and from that we construct labor productivity or all-sheet productivity. Okay, so how did we come up with that? So basically, we know total output from the tax. Okay, and from the historical record, we know that on average, one kanat was actually worked by a husband and a wife. Okay, so basically, one kanat was worked by two persons. So our labor productivity is equal to a half times total output divided by amount of kanat.
May I have just a quick question right now?
Sure. Yeah.
I'm just wondering that for the tax rate, is that the same for all kinds of the agricultural products?
So this is all-sheet. This is the tax rate for all-sheet. So we don't have a tax rate for, say, paddy field, for paddy, okay, for rice, but this cover a range of fruit trees as seen in the table.
And that tax rate is constant, right?
Yeah, constant over the rain, because it's very costly to survey, like for the officers to go out and count trees and evaluate. So it was done just once per rain, and it's constant. You can grow more trees over the rain, but that would be
So we can rationally assume that this really reflects the productivity exactly.
Yeah.
Underestimate or overestimate.
Yeah, so it's kind of the lower bound for the estimation. Yeah. Thank you.
Thank you.
Ka, next, Ka. Thanks a lot. So here is the summary statistics. So you can see that for the first category, canal variables. So we have both transport canal and irrigation canal. This is because we want to distinguish the effects of transport from water input. Okay, so for canals, it could bring water as well, but we wanted to clearly estimate transport effect. So luckily, in the orchard deeds, okay, when they say Klong, they actually had another term, Lam Gradong, which actually means irrigation canals. So they were like smaller canals, just enough to put just small boat, not for transport, but those canals for irrigation purposes. Okay, so we have these four mutually exclusive categories for canal. They are dummy, like so whether the property bordered just a transport canal, just irrigation canal, both transport and irrigation canal, or none of them. Okay, you can see that about 42% of our properties bordered transport canals. And then we have plot characteristics and even owner characteristics. So we can say whether the owners were female or male or nobility or Chinese. Okay, so Chinese would have D in front of their names. Okay, yeah, next please. So let's quickly come to our empirical strategy and baseline results. Okay, so baseline empirical strategy is simple. So basically our YI, so we have this cross-sectional data. So YI is productivity, labor productivity of household I, and we have dummy for transport canal, irrigation canal, and transport and irrigation canal, and we have X's as control characteristics. So what we are interested in is the estimated beta 1. Okay, so next slide, please. So these are baseline result. Okay, so basically if you look at column 3, where everything is put in, you can see that if the property bordered transport canal, the productivity which was in log was 7, and properties that type of canal. So this is statistically significant and sizable as well. Okay, and boarding irrigation canal actually have a positive effect as well. Both transport and irrigation canal has
May I have another quick question?
Sure, of course, yes.
I was just wondering why the borders irrigation canal only has higher impact on it.
Yeah, could be that because water is very important for orchard. Yeah. So here we in the paper we didn't highlight this because it's kind of more straightforward effect of water input, but we showed here as well that is important. But it's a very good question, because if you see the effect of borderings are transport and irrigation canal, the plot that has both types of canals, the effect is 0.172, which is actually less than the sum of transport and irrigation canals. So this in the paper, we explained that it could be that there are some functions of transport and irrigation canal that overlapping. Okay, for example, transport canal actually can carry water as well. So in the end, bordering 2 is not as big as the sum of both. Yeah. Okay. Okay. Thanks. Next, please. Okay. So here comes the crux of the paper. So although we see positive and statistically significant effect of transport canal on orchard productivity, we have some concern about endogeneity effect. So for those who do empirical work, so we have to be always concerned for endogeneity effect. Okay, so here our concern is about unobservable selection. Okay, so let me expand on this a bit. So we have a concern that orchardists, okay, may sort into plots that adjacent to canals once new canals were built, okay, because we have only cross-sectional data. So what we observe is the the end-line shot. Okay, so we don't observe the shot beforehand. Okay, so we concern it could be that high productive cultivators sort themselves into the land near the canals. Okay, or it could be that inexperienced cultivators actually constitute a group that claim the newly opened land because they are kind of new to the business. So when the new lands were opened by the canals before the time, so from the time of Ratanakosin to King Rama V period. So there could be either highly productive or inexperienced cultivators sorting themselves. So we concern if the characteristics of those who were on the canals are varied systematically according to their productivity. So that would cause our endogeneity concern either way. Okay, so this is especially a concern in sparsely populated area. So let's think about densely populated and sparsely populated area. There's a higher probability that people would sort themselves into the more sparsely populated area because it's easier to settle down. That there were no other people settling down there yet. Okay, so here so here is a newly connected land with sparsely populated neighborhood would have a higher chance of the selection problem. Okay, next please. So here so usually the standard method could be using IVs, okay, or panel data that we don't have an IV in this case is very hard to find. So we actually use the new method developed by Oyster 2019 to address self-selection issue. So basically, Oyster methods actually try to evaluate the coefficient estimates, okay, the robustness of the beta hat that we found as 10.7%, 0.107, whether it's robust to the omitted variable bias, our selection bias, under the assumption that we can express the relationship between the treatment, which is bordering transport canal, and the unobservables, okay, this relationship, okay, can be recovered from the relationship between the treatment and the observables that we are already known about, okay? And then under the range of possible R square, we attempt to find the value of this relationship that can drive the coefficient that we found in table 3 to 0. Okay, so let's say that if the endogeneity effect, the selection bias, whether it's big enough to drive what we have found before to 0, i.e. no effect. Okay, so if that could be true, how much and which direction of the bias has to be. Okay, then we investigate further that the value that we find is possible in the setup. Okay, if it's not, then we say that we are saved from the self-selection concerns. Okay, so let's see how we did that. So the first line is actually the relationship defined by Oyster 2019. So basically, the term, say on the right-hand side, sigma 2 canal over sigma 2 square 2 is the correlation between the observables or the control variables that we put in and the canal variable. Okay, and we say that is equal to delta sigma 1 over sigma 1 square, which is the correlation between the unobservables, i.e. omitted variables that we don't know that could be selection bias, and the canals. Okay, so that if we know the right-hand side, and if we know the delta, we can recover something about the relation or correlation between the unobservables or the bias and the canals. Okay, and then we use the standard bias estimation, the second line. Okay, so if we say that beta star, which is the true parameter for correlation between canals and productivity is 0. Let's say that if we drive this down to 0, there's no correlation as such or causation as such. Okay, how much delta it has to be. Okay, so we know beta hat from column 3, the regressions with observables, beta tilde is from the one with no controls. So we put values in as you can see below. Then we have an estimate of delta, which is a function of R max. Okay, and R max goes from 1 downwards until the R hat that we have in column 3. So basically, it's quite clear from this equation that delta has to be negative always. Okay, so in this case, if what we have found is not true, okay, delta has to be negative. Okay, so next, please. So let's see, what does it mean when we say that delta is negative? Okay, so when delta is negative, it's actually implying that we need positive correlation between unobservables and the canal variable to drive the effect that we found earlier down to 0. Okay, why? It's because if we go back to column 1 and column 3 of table 3, we can see that the estimated beta hat for the transport canals actually was bigger in column 3 compared to column 1. Okay, thank you. So what does it mean? So it means that when we haven't actually put other controls, the result in column 1 must be downward bias, right? So it must means that there's a negative correlation between the controls and the canals itself. Because once when we put all the controls in column 3, the coefficient of transport canals actually bigger. Okay, so here we know that, so I'll pause there. Can you go back? Go ahead. Okay, the delta, oops. Back again, please.
Where?
Sorry, the delta
The
and
table?
correlation.
Okay.
No, back again. Yes, there. So we know that delta is negative, okay, and the alpha 2, okay, so the correlation between observable and canal is negative. So it must be that the correlation between the unobservable and the canal is positive. Okay, so can we go to next slide? The last slide that we were talking about. Okay, all right. So here, so how are we going to put this in economic terms? It means that the omnitive variables that we were worried about, okay, self-selection, the nature of the self-selection has to be in such a way that highly productive orchard discs sort themselves into the location next to the canals, okay, so much so that their productive characteristics drive away the impact of canals in our original estimation. And then we cannot interpret it as causal interpretation. Okay, so now next we are going to see that with all the available information that we have, whether positive selection that we defined is true, actually happened. If it didn't, then we can say that this raised some doubts in our previous finding. Okay, so we make how not into us was more likely in the areas that I'm back. Am I back? Okay. Can you guys hear me now? Hello?
Yeah, yeah.
Yes,
Yeah.
yes,
Okay.
we can hear
Okay.
you.
Thanks. Okay. So other things being equal, okay. So if we compare so if we say that more productive orchids actually more likely to sort themselves into the area that's more sparsely populated. So if we compare the area with canals, okay, we should observe higher productivity in more sparsely populated area because they have more productive orchids sorting themselves into. Okay, so next please. So here we make assumption about population density, but we don't have population density back in the time of King Chulalongkorn. So what we did, so we made further assumption that actually we can proxy population density by tempo density, okay, because we have tempo data, okay, which had a date of a tempo when they were constructed, okay. So we construct tempo density, which is the number of tempo per square kilometer in subdistrict S at various points in time, okay. So from historical and archaeological records, okay, temples can say a lot about population density because you need a number of population and wealth to have a community and have temples in. Okay, so next please. So these are maps of temples and then different types of dots represent the time of the construction. For example, we have 1767, that's the fall of Ayutthaya period. And then next is the period of Bernie Treaty, and then 1855 is the Bering Treaty, and then 1867 is 10 years before the Orchard Survey was conducted. Okay, so we have like kind of the measure for population density for each period. Okay, next please. So here's the next crucial regression equation. Okay, so just emphasize again that if in less populated area, it was more likely for productive orchids to sort themselves to gain access to transport canals than in more populated area. We should expect to find that beta 3 in this equation to be negative and statistically significant. What is beta 3? So if you look at this equation, is the coefficient of the interaction between transport canal and tempo density. So it means that if these two households have the same, if they were connected with a transport canal, okay, but those which were in the area with higher tempo density or higher population density should be less productive, okay, because in the in the more sparsely populated area, we expect to have more productive orchids to move to live on the canals, okay. So if the selection bias is true, okay. So next please. So next is the results. So here you can see that in each column is a population density or tempo density defined by different periods. And what we are interested in is in line 3, row 3, which is subdistrict tempo density interact with transport canal. So you can see that although they are negative, they are insignificant, which means that insignificantly not different from 0, i.e. we don't actually find any evidence, supportive evidence for positive selection, okay, positive sorting into plot next to the canals, okay. So just to recap, beta 3 in all regressions are insignificant, okay, suggesting that no positive sorting. And this, if we work backward as we work forward earlier, this suggests that a negative delta is not likely to be the case, which means that, okay, the the bias, I mean, the selection concerns shouldn't be the case. Okay, so we can actually interpret the effect of boundary transport canals that we found earlier in table 3 as positive and causal. Okay, so we kind of safe in saying that what we found is not actually tempered with a selection bias. Okay, by working through the Oyster 2019 methodology. Okay, so once we have established the causal effect between having a transport canal by your property and your productivity, then we further estimate welfare implication. Okay, so this is one of the advantages of our data, that we actually have household data compared to literature earlier that look at aggregate level, so we can actually find impact on household welfare welfare. Okay, so basically we calculate profit, okay, of representative property. So we assume that representative property is areca nut orchard, because about 90% of the orchards grow areca nut, and then we have the estimated of revenue, input costs, and taxes. Next, please. And then if you look at this table, in the end, we found that if you have canals by your property, okay, your profit would be 13 to 32 bahts higher than properties that had no canal adjacent to. Okay, it's a median and mean property. And translated into economic term, that was equivalent to about 17 to 42 days, 17, yes, to 43 days of manual labor wages, which was quite sizable. Okay, so to wrap up, so the conclusion is that although this is a study that used historical data, it could shed light on current development economics issue as well, because our results point to the role of expansion of access to transport infrastructure that can play in reducing transaction costs, and then incentivize households to cultivate perishable crops more intensively. Perishable is important here because these are perishable fruits, so transport is very important to save costs. Transport cost and time is very important. And the results suggest also yes, please, next, please. Next slide. Yeah, the importance of the last mile problem, which is important in recent development literature, that actually if you have infrastructure, but if it failed to connect to the final user, then it could be quite useless. Okay, so here we show that it's not just having networks in your area or locality, like having like direct connect to those lines actually have a marginal, sizable, significant marginal effects. Okay, so that's it for our paper. Okay.
Thank you very much อาจารย์ธัญพรค่ะ